I'm Hema. My mentee was Isabelle, and she's a really enthusiastic, really busy sixth grader here. And she's very passionate about the environment and animal conservation as such. And she was very interested in learning something about machine learning. And so as part of her project, she's basically married these two interests of hers. And within a span of like 3 months, she's basically picked up Python, which was a new language for her, and also done this really amazing project. So kudos to her.
Hi, I'm Isabelle, and if you haven't guessed, I'm part of the Magic program at Castilleja. Before I tell you about my project, I would like to tell you about another very important part of this process, my mentor, Hema. Hema is an amazing mentor. She was constantly encouraging me and helping me every step of the way. I came into Magic with no knowledge about machine learning, and she has been super patient with teaching me and answering all of my questions. She has helped me so much throughout this project, and I couldn't have done this without her. Also, one of the coolest things I learned about Hema was that she has been to the Wave in Arizona. Do you know what the Wave is? I didn't. I had to look it up. But I learned that the Wave is a sandstone rock structure formed because of erosion over 190 million years, and only 10 people are allowed in a day. And that is a picture of the Wave. My project is a program that can inform you whether an animal is endangered or not. I was inspired to do this project because of my love for animals and because I want to bring more awareness about them. I am using the GPDD, or Global Population Dynamics database, to find out what that animal's population is. And I have used Python to code my program and faced many challenges. At the start of Magic, I was learning how to code Python, and I learned about loops, variables, if-else statements, and so much more. I've also learned a lot about machine learning, including what it is, different types of models like K&N, K-nearest neighbor, image classifiers, and decision trees, and of course the importance of good data. We searched for a public database on animal populations, and it took a long time, but we eventually found the Global Population Dynamics database. But it was a Microsoft Access database, and so we couldn't access it because we didn't have a Windows computer. And so after a lot of searching, we found a package called R that we could use to turn it into a TSV file so that we could read it on a Mac. I like to say that my program is only as good as my data. In the GPDD, we don't have access to the population of every animal, and the populations were all sampled at different times, and so the populations can be not accurate, and my program can predict stuff wrong. Some of the challenges I've had with my code include debugging and syntax errors. Wow, that's a lot blurrier than I thought it was going to be. That's a picture of how the GPDD works. As you can kind of see, there's a bunch of tables with a bunch of different files within them, and our goal was to get the animal's name and population, but to get there, we had to go through many tables and files, and so we started out in the taxon table, and we got the taxon ID, then we went to the main table, compared the taxon ID to the main ID, and then we went to the data table and compared the main ID to the data ID, and when we finally had the data ID, we could finally get the population of that animal. Some other challenges I've had with my code is searching multiple CSV files at once, and then realizing there was multiple main IDs for every taxon ID, and so the numbers didn't line up, which made it a whole lot more complicated. Hema was super helpful through this process in helping me figure out how to write my code and where to put it. One of my big takeaways is learning all about machine learning. I learned that machine learning is a way to teach the computer how to answer a specific question, and I've learned so much about machine learning. Another big takeaway is my Python coding, and I've done so much in Python, including reading and writing files, looping through files, comparing numbers and strings, and learning how to use lists and dictionaries. I've become more confident in my coding and figured out my own ways to solve problems. These are 3 pictures of the code that I've written. The one on your left is the first one, and we wrote that code basically to get the information that we needed and transfer it into a file that we could read. as you saw in the picture of how the GBDD works, there's a lot of information that we didn't need, and so we had to go through every table and file that we needed and compare and read how they match up. In the second one, I imported a decision tree from scikit-learn, and I was training the model, and how I train the model is I give it populations and labels, and so hopefully that computer can find a relationship and then accurately predict the next time I give it just a feature. And in this case, my feature is my population, and my label is whether the animal is endangered or not. In the third piece of code, we were taking user input, and so how my program works is the user will provide an animal name, and my program will go through the file that we made and see if it can find that animal. And if it can, it will take the population, compare it to a recipe, which is basically a rule telling the computer whether that animal is endangered or not. And it's the recipe is in the bottom line. It says if population count is less than 500, that animal is endangered. And so that is a recipe, and it will compare it to the recipe and print whether the animal is endangered or not. If it doesn't find the animal in population, it will print population not found, provide population of this animal, and the user can, if they know, put the population in there, and it can still print whether it's endangered or not. The two pictures on the sides are pictures of my code, and the picture in the middle is a picture of the file that has the animal name, the population, and label. I did some of my own research because I wanted to see how accurate the database was, and so I just picked northern flying squirrel, and the population here, it says there's 34, and I found on a .gov site that there's 33 northern squirrels, and so this shows about how accurate our database is, and there's obviously some that are not going to be accurate, and because of this, it is possible for my code to predict wrong. Like I said, my program is only as good as the data I have. Thank you.